Okay, so we're going to start off chapter 4 with factoring. Like I said before, class example 1 is called GCF factoring, and class example 2 looks like some difference of squares. So jot that down on the side. Hopefully you've already done that. We're going to put GCF right here, greatest common factor. So we're looking for something that divides both terms, and then whatever that thing is, we're going to pull it out to the left. We're going to factor it out. So 15 and 5, what's the biggest number that divides those? 5. And then how many x's are shared between an x3 term and an x2 term? 2, right? So at most, you can factor out an x squared. Now in your head, you open up the bracket, of course, but in your head, you're imagining dividing both of those terms by that common factor. Okay, so we have to take this term and divide it by this. Let's do that first. 15 divided by 5 is 3, and x3 divided by x2 is x1. Okay, and the last term? Good, some people are saying it. 5x squared divided by 5x squared is 1. And the sign was negative, so we keep the negative, and we put the 1 there. Okay, I did see one person, they just went like this. That was what they factored, because they thought maybe 5x squared divided by 5x squared was 0 or something. I'm not sure why. But how many terms to begin with? 2. So whatever you factor out, there's got to be 2 terms left over. How do you double check that you've done this properly? If you multiplied back in, would you get what you started with? Okay. All right. Now looking at this one. What do you see in common? Always check the variables first. I do that first. Does the last term involve the letter P? So you cannot factor P out of all 3 of them. You could only factor P out of the first 2. So we're looking for a common factor, so we can't use the letter P. We've got to jump to the numbers now. What's the biggest number that divides 8 and 4? Take 4 out of each one. It's like you're scaling them down. So this would be 2p cubed minus 1p squared minus 1. Last one. This is also GCF, but the GCF's a binomial, so you guys might get thrown off a little bit by that. So they both have a y plus 2 factor in common, so we can divide it out. Imagine you're doing this to both. This is what you imagine in your head. You don't actually write it, you gotta kind of just imagine it in your head. It's like in your mind's eye. So it's like, okay, so then what would be left over after those are removed? You have so I always bring out my factor to the left, and then the leftover goes to the right. So you'd be left with a 3y and a minus 9. And then I put a little note for you here. Always check for more. Always check for more factoring. Because what do you see with that 3 and that 9? A common factor of 3, right? So this one keeps going. Y plus 2. And I'm going to take a 3 out of that term, but I'm not going to put it in the middle. I'm going to put it all the way out to the front because it just looks nicer. And then I'll go y minus 3. You guys okay with that? Any questions with that? So the 3 came out of this factor, but I'll put it all the way over to the left because that's where coefficients go. It just looks nicer. How you guys feeling? Feeling okay? Only one? Everyone else is just depressed, hey? Okay, difference of squares factoring. Put that over here. Difference of squares. So we have the formula. A difference of 2 squares will always be their corresponding roots. So if x square is the square, obviously, x is the root. And then in order to make the x squared minus y squared on the left, if you were to FOIL all this out, here would be the x squared, here would be the y squared, and in order to get the middle term to disappear, one of these has to be positive and the other one has to be negative. That way when you FOIL it out, you know when you FOIL it out? Do you know what I mean by FOIL it out? You get those 4 terms, the 4 terms in the expansion. You should be aware of this. And then the 2 in the middle usually collect. You know that? Well, on the difference of squares, they will disappear. So these ones are x minus 9 and x plus 9. You just use the roots. So this one would be 5a and a 7. You guys okay with that? If I go fast on these, 1's minus 1's plus, it doesn't matter what order you put that in. Now this one, can I do this one? Why? It's a sum of squares, not a difference of squares. We can't factor sums of squares. Whoa! We cannot factor the sums of squares over the real numbers. Okay, so that's something you might come across later in your studies, but right now we cannot factor those. Over here, 16t and 64, it's going to be 4t and then the other one will be 4t minus 8. So what's the problem? What do you notice about 4 and 8? They have something in common, don't they? They have a factor in common. So what could I divide out of the first term? 4. And what about the second term? Whoops. So you have a t plus 2, and then you'd have another 4 come out, and you'd have a t minus 2. The 4 and the 4 would come together as 16. And then you have this t plus 2, t minus 2. So notice, did I do the GCF first or last? Last. So what if I had done the GCF first? What do 16 and 64 have in common? Yeah, they both divide by 16. Very good, Carl. So if you take out a 16 right off the bat, you get t squared minus 4. And then you can do a difference of squares on those, t plus 2, t minus 2. A little bit cleaner. I often tell students do the GCF first because, you might forget. You might get to this step here in the box and you're like, oh, I'm done. Okay, so I always tell kids, look for a GCF first. Okay, so when do you do the difference of squares? That's the question. Like, how do I know I can do difference of squares for these? Because I told you on the left, or because what? 81, 25, 49, what are they? Perfect square numbers. So only do that when you have perfect square numbers. Does that make sense? Okay. Okay, now the trinomials by inspection. Do you remember when you have to think back to last year? I'm going to do this on the side here. You got this ax squared plus bx plus c. And in this case, the a will be 1. So when you see that the a is 1, you're going to use this word in your head, inspection. Okay, so that a is 1. So it's basically not there. You just have this, x squared plus bx plus c. These are by far the easiest things to do ever. Okay, they are easy. All you have to do is think of the two numbers that do what? Multiply and times to what? The b and the c. They have to add up to b and multiply to c. You need two numbers that meet that quality. Two numbers that do this. I used to call them in Math 10 the magic numbers. So what are these magic numbers? Okay, so let's take a look at the first one. Excuse me, sir. Khalil, really? Go to class. Okay, back to the math. When you look at the first example, I don't want you to get confused. You notice how they're using the variable a in the formula, or this polynomial here? Don't confuse it with what I have written here. I always go a, b, c because it's the letters and the coefficients. So, but what's the variable that I'm always interested in? X squared, x, right? So you have to think of this a as like that's the x. Does that make sense? Okay. So in this case, I would say that the a value is 1. Don't get it confused that they're using a here. You could use anything there, x, y, z, apple, whatever. Okay, so what are these magic numbers that work here? What two numbers multiply to 30 and add to 11? 5 and 6. Now, if you didn't get that quite quickly, you can do a systematic list with 30. You can jot down all the factors of 30. Are there more? I think those are it. Now you look at those numbers. Which one of those add to 11? Okay, so if you're not quite good at this process of where, like, what are these two numbers? Maybe your times tables suck or something like this. You start here. You have to start at the product. You can't start at the sum because you can think of infinitely many things that add to 11. But you can't think of infinitely many factors that multiply to 30. Okay? So it gives you a list to work with. Now to factor this, you go a plus 5 and a plus 6. That's the factoring. The 5 and 6 and the plus signs because these are positive. Was that your question? Yeah, these are both positive, so that's why we put positive 5, positive 6. Okay, and then if you don't believe me, let's FOIL it out. So a times a is a square. A times 6 is 6a. 5 times a, and then 5 times 6 is 30. And then you collect the middle term, you get a squared plus 11a plus 30, back to where we started. Okay? So this whole idea of factoring and expanding as inverse ideas. If you expand, you get to the sum. Okay? So if you start off when you're factored and you expand, you get to a sum. If you factor, you get back to a product. And that's why factoring is critical. It gets us to products, and products are way easier to work with in equations than sums. Okay, magic numbers for 30. What multiplies to 30? We already know them, right? So let's go back to this list. Which one of those numbers is going to give us a sum of -1? It's weird, right? It's 5 and 6 again, right? You just have to manipulate the positive and the negative. Okay? So which one's going to be negative? The bigger one, right? If you add two numbers and one's positive and one's negative, the bigger one has to be negative to end up negative. Okay, so it's going to be b minus a 6 and b plus a 5. Because that's the only way you can get to -30. -30, the two magic numbers, if you will, they have to have the different sign. And the last one, 48. What multiplies to 48? 1 times 48, 2 times 24, 3 times, oh my gosh, 3 times what? Does 3 even work? 16? Does 48 divide by 3? Good. And 4 is with 12, and 5 won't work, and 6 is with 8. And that's as many as factors as are possible. Now, which one of those has a separation of 4? Will any of those work? Doesn't work. Keep going. To the next question. There's no more factors. So you say not factorable. If you cannot find those two numbers, you can't do it, and you have to say that that polynomial can't be factored. So why can't it be factored? You know those algebra tiles? Remember those things? No, you can't GCF it. We're talking about this one here, right? Remember those algebra tiles? You don't know what an algebra tile is? It's like the square, the little square, and the rectangle, and you try to line them up. You wouldn't be able to make a rectangle with 48 little squares and 4 of those longer rods, if you call them, and then one big square. You wouldn't be able to make a rectangle. That's what it's saying. Because a rectangle has a length and a width. See this? A length and a width. So that's what factoring is. You're organizing these terms into a rectangle. And if you can't make a rectangle, you can't factor it. Okay, and some you'll come across, they won't be able to factor, and you got to know that. Okay, last one. GCF first, right? Someone spotted it right off the hop, right? So what is it, 3? And I always just check the lowest number. Check the lowest number. If they all divide by the lowest number, just go with it. And then if that doesn't work, go lower than that. Okay, so they all divide by 3. So is there anything more than the 3 though? X. So you get an x squared minus a 7x and plus 12. Okay, am I done? You always check for more, right? So I'm pretty sure I see, what do I see? Do I see this structure over here, this structure here? This x squared bx plus c? And is the first term 1? Then it's super easy. It is 1. See, look, it's 1. Okay, so Carl said 3 and 4. Is he correct? Kind of, right? He's on his way there. -3 and -4. Because those two negatives would multiply for a positive 12, right? And they would add up. When you add two negatives, they get more negative to -7, right? Okay. So factoring these polynomials, it takes a combination of your number sense with times tables and also your ability to add add integers. Okay, so you know what happens when you add a positive and a negative, what happens when you add two negatives. Okay. Now this step here, this factoring by grouping, whatever that was, please put it away. The factoring by grouping, this is like a preliminary step to factoring these guys when the a value is not 1. When the a value is not 1, it's a little bit harder. You got to do a little bit more of an algebraic step, and this right here is a preliminary step. So they're showing you the preliminary step. It's like a warm-up. So why do you see 4 terms? Any hints? Any guesses? What happens when you multiply something like this? You get the 4 terms, right? Whether it's plus or minus, I don't know, plus or minus, I don't know, whatever it is. But you get 4 terms, right? So that's what they're trying to do. They're trying to get you in that idea. So what you're going to do is you're going to put them into pairs. You're going to put them into pairs. Because altogether, they don't have a GCF. But in pairs, they do. Okay? So right there, I see no GCFs. But in pairs, I'm like, GCF, oh yeah, I feel happy. That's a smiley face, I think. There, stick his tongue out. Ah. Okay, so what's the GCF in the first pair here? So take an x out, you get x minus 5. Any comments or questions about that? In the next one, what's the GCF for the 2 and the 10? And no x, right? Okay, so take out a 2. And I'm taking out a positive 2. Make sure you write that. Kids don't write this all the time. Write it. This little positive, write it. I'm being so serious right now. You don't write that, it messes you up. I promise. Then you get this x minus 5. Now it looks very familiar to something we started with right off the bat. Remember this one up at the top? Remember they had this y plus 2 in common? It's the same stuff. So now they have x minus 5 in common. Take it out, and you get this x and this 2 left over. Do you guys see it? So it's like there, and like right there. Yeah, very good. Very good. Okay, let's do this one over here. I see no GCF off the hop, right? First line, no GCFs. But if I put them in pairs, and I love this little upside down square bracket, because then I can write in GCF here and I won't forget. You could manipulate the pairs, yeah. Yeah. But typically when you write out your polynomials, the highest degree is on the left and the constant's on the right. You could manipulate these 2 and the 9s. The 2 could go over here and the 9 could go over here. That would be okay. But I would keep the biggest power off to the left and the constant off to the right. These y's, like, first of all, wouldn't you just use collecting like terms and you would put those together? Okay, so that's like why are we doing this? Shouldn't we just collect like terms and go like this? So later in the next page, you're going to be given this. And then the question is like, well, why do you split 11 into 9 and 2? So think of the magic numbers. What does 9 times 2 multiply to? Same as 6 times 3. Okay? Okay with that? And what does 9 plus 2 add up to? Of course, 11, right? So that's where we're headed. Anyways, let's finish this off. Enough with the peanut gallery back there. And we're going to GCF pair these two. What comes out of 6 and 9? 3y. Good. And you get a y plus, thank you, 2y plus 3. Now, is there a GCF for 2y and 3 on the other pair? There technically isn't other than 1, right? Everything divides by 1. So what you can do is pull out a 1 there. It's not going to change anything. If you divide by 1, it's not going to change anything. Now they have 2y plus 3 in common. And the 3y and the 1 sort themselves out. Good? Okay. I love this factoring flowchart. It's beautiful. This thing right here. Next page. Yeah, use it. Read it and use it, okay? It just tells you the guidelines for factoring. You know, start with the GCF, and then if you're in these different situations, do this. And then at the bottom it says always check for more. Okay, let's take a look at this. Let's use the factoring flowchart. What does it tell us to do right off the bat? Look for a common factor. Let's do that. 36 and 9. Oh, they both divide by 9. Take out a 9. You get 4 minus x squared. Does that look weird to you? What did I just say on the last page about the constant being on the right and the highest power being on the left? So rewrite it so it looks more natural to you. Negative x squared plus 4. This is also weird. The fact that there's a negative on the lead coefficient. I personally hate that. So to avoid it, I factor out a negative. So I'll take out a negative 9. That negative becomes positive, and that 4 becomes negative. That's a skill that you can use at your disposal whenever you feel it's necessary. Factoring out negatives. Because all you're doing is changing signs. When you divide by 1, the number will not change, only the sign will change. So I could have did this question a little bit differently right off the hop. I would have said, well, I noticed that the lead coefficient, you guys know what I mean by that? It's the coefficient on the term with the highest degree. It's negative. If the lead coefficient is negative, I will probably factor out that negative. So right off the hop, I'll take out a negative 9, and then I would get a negative 4 plus an x squared. And that just looks weird, so I would, myself personally, I would do that rearrangement all in the same step, and I would get to this x squared minus 4 in one step. I wouldn't even do this step that's start. But I'm pretty confident. If you guys are not, show all your steps. Because if I walk over to your aisle and I'm trying to help you, or you're asking me to come over, if you have lots of steps laid out, then it's really easy for me to find out, you know, what went wrong. A lot of kids, like, they'll come, they'll be like, I don't know what to do. And I'm like, okay, well, like, what do you mean? You don't know what to do? I just don't get it. and then it's really hard for me to help you. So if you have the steps laid out and you have a very specific question about what the problem is, then I can help you. It also saves me time from like trying to figure out what you did. Especially on the written response on tests, please show all your steps and in the order, right? Think if I'm marking 30 exams and I'm on like, you know, an hour and a half of doing this, and your test comes up, and I'm kind of stressed out because I've been marking these exams late at night, and yours comes up and you don't have any work showing, and I'm like, oh, whatever, 0, next, right? It's about self-preservation, right? So do your best to show all your work, and it's going to make your life better. What do you see in the coefficient in the lead? And why would they write it like this? They're just trying to mess with you. It should look like this. And what do you see here? That just bothers me, right? So take it out. Take out a negative. Are you writing anything, Kyle? Okay, now what do you see in the brackets? What structure is this? This one? What is the A1? So this is easy. Bracket, 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 bracket. What's the magic numbers? 7 and 4? What were the other options for 28? 28 and 1, 14 and 2, 7 and 4? So it has to be 7 and 4, right? No way these two are going to get you there. So put 7, put 4. Which one's negative? 4 or 7? It ends up negative, right? Negative 3. So the bigger one has to be negative. Now a negative 7 and a positive 4 make a negative 28. A negative 7 plus a positive 4 gives you a negative 3. Slap the x in there, and life is good. Okay, try some homework. Okay, let's go like 1A. One C, 2A, 2B, 2G, 2E, and 3A, 3G, and 3I. Do all these right now, and then I want to move on to the next lesson. Okay, well let's go to lesson 2 there, because it's all similar stuff, and it's all review of grade 10. So we jump into lesson 2, or of math 10, pardon me. Okay, so we're not going to be doing algebra tiles, that's for sure. Okay, and I'll show you this. It's the exact same thing, but not with algebra tiles, with an area diagram. Okay, and before we do this, I'm just going to show you a nice little technique for multiplication. So imagine you had to solve all the world's problems, and it was 12 times 13. And you didn't know how to do that. And you didn't have a calculator. Check this out. 12 is the same as 10 plus 2, and 13 is the same as 10 plus 3. And then we can multiply this using FOIL, right? But rather than using FOIL, let's just use an area diagram, a multiplication chart. If you put 10 here and 2 here, and 10 here, and 3 there, you could quickly multiply this. 10 times 10 is 100, 10 times 2 is 20, 3 times 10 is 30, 3 times 2 is 6. Add all this stuff up, it's 156. Pretty sweet, eh? Multiplication chart, area diagram, distribution, all wrapped up into one nice little diagram. Okay? So I'm going to show you how to do that with the polynomials. Okay? So with the polynomials, remember the this structure here? Do you guys remember this structure? What were we looking for? Two numbers that multiply to c. Well, that's because the a value was 1. So it was like 1 times c to make these rectangles. So we got to actually do the a and the c. So we're going to put a little diagram like this. AC equals 10. So we need two numbers to multiply to 10 that also add up to 7. So this is a weird one because it's like identical. It's 2 and 5, right? So we want to break this rectangle into not this rectangle, this polynomial into 2 and 5. So check how I do this. And this would be the same organization as the algebra tiles. So 5x squares and a 2. And then we have to split this 7x up into those magic numbers. What were those magic numbers again? 5 times 2 is 10, and 5 plus 2 is 7. So the numbers are 5 and 2, right? So we'll split them up like this, 5x and 2x. Yeah, Chiming, turn that music or sound all the way down. Okay, so what we're going to do is we're going to pull out a GCF this way. Grab a GCF. So what's in common with the 5x squared and the 5x? So put it there. And then you just play a nice little rectangle multiplication game. 5x times something is 5x squared. Just x. 5x times something gives 5x. 1. X up here times something is 2x. 2. And then we have 1 times 2 is 2. We're good. So all this stuff inside, that would be like the area inside, is equal to the length and the width. So the length is 5x plus 2, and the width is x plus 1, and she's factored. And I didn't even have to do any algebra, which is nice. That's it. So how would you do this by decomposition? This is what you were probably taught last year. Do you guys remember? What do you do with that middle term? You have to decompose it. Remember that? So you would break the 7x squared into a 5x and a 2x. And then you do what I showed you on the previous lesson. You put them in pairs like this. What's the GCF for that first pair? 5x. You factor that out, you get x plus 1. GCF on the other one is 2. You get x plus 1. Now you have x plus 1 in common. You take it out and you get 5x plus 2. Similar, right? Which one's easier? You like the algebra? You don't like the box? The box is easy. I personally didn't know about the box until I was like 23 or something years old at the university. And I actually guessed and checked in high school. That was crazy. Because I must have missed the lesson on this. I guessed and checked even in 30, it was called 30 period then. I guessed and checked my polynomials, which was hard. I would guess these. I'm like, well, it's got to be 5 and 1, and then 2 and 1, and then I would try things, and then hopefully I'd get it. Okay, so which one do you guys want me to stick with? This stuff or the box? 1 or 2? 1? Okay. We are a democracy in here. Yeah, that's called method of decomposition, and that's what the book does, and that's what I'll do, okay, for you guys. And personally, nowadays, I use the box. But it's up to you guys. Okay, so let's take a look at this one here. You look at this question, you're like, all right, what do I do? I'm in a test. Oh my gosh. GCF, yeah? Is there one? Well, 7's prime, so throw that out the window. Am I in this structure? Yeah. Do you see a square, a 1, and a constant? So you have this structure. Is A 1? Oh, if A is 1, it's so easy, right? You just find those two numbers, boom, you're done. Remember? If A is not 1, you do this decomposition business, okay? So what I like to do is I like to jot down these little arrows like this, and that AC value is 12, and the B value is 7. What numbers multiply to 12 and add to 7? 3 and 4. Good. That's an easy one. We take these numbers. I'm going to change the color on those numbers. And then that's how we break this down. Does it matter if I put the 3 or the 4 first? It does not matter. It will work. If you found the two numbers, it will work. Yes, sir. Yes, it would be, right? You could think of it that way. Yeah. It ultimately won't matter. Because 4 and 2 go together and 3 and 6 go together. Yeah, that's good. But it'll work. So then 2x squared, and we have a 6. Those outside terms we just copy. We just break the middle. Why do we break the middle? Because now there's 4. What do you get from a FOIL? A FOILed expansion, binomial times binomial, outputs the 4 terms, right? This is why we do this. Now I like to draw these little under brackets. I love those. Some of you guys actually just draw the bracket around those. I despise those. But you do whatever you think you need to do to have success. You should probably trust the guy up at the front, though. What's the first common factor? Only x, right? You take that x out and you get 2x plus 3. Now, you want that 2x plus 3 to show up again, or else you've screwed up, right? That 2x plus 3 better repeat itself. You need that repeated binomial. So how are you going to get a 2 and a 3 to show up from a 4 and a 6? Take out a 2, right? 2, positive, right? And then you get 2x plus a 3. Now they have the 2x plus 3 in common. And you go with x plus 2. Yes, sir. Uh-huh. No. Where were you like 30 seconds ago? We literally just said that. It's all good. It's all good. You're in school all day and all you hear is this, so I get it. I get it. Okay, next one. Did we just do this one? No. Don't even lie to me. Okay, let's do this one. Okay, where do we start? Okay, 6 and 3 make negative 18, and then we got to get to 17. So how's that going to work? What multiplies to 18 and gets to 17? Yeah, it's the easy one. It's the one that everybody sometimes forgets about. If the sum and the product are like just one off, it's the trivial factor. Like when you times by 1, you get yourself. It's always going to work like that. So it's going to be 18 and 1. Which one's negative? The 1? Good. And I'll put that in a different color because I often just put down the numbers and then decide on the sign. Because it's like too much things for the brain to comprehend. Figure out the numbers, get it sorted out, and then decide on the sign. And then be super confident that you've chosen that properly. Don't just start factoring if you're not confident in those two numbers, because it's just going to be a waste of your time. Okay, those two numbers break down the middle. 18x minus x is the same as 17x. Copy down the front and the last. And now put those square brackets in. What's dividing 6 and 18? 6x, you get x plus 3. And then I see x and 3 coming up again, but the signs are completely different. So what's that trick? Factor out the negative. That's a trick that you got to be aware of. It will show up in your life, in your math classes. Not in your life. Math wouldn't show up in your life. Just kidding. Math is life. Math is my life and it's miserable. I'm just kidding. Okay, I like to do these fast. 3 and 8 make 24, and then we got to go to a -2, and I'm stuck. I'm like, okay, what multiplies to 24? Oh my god. Don't give it away, you smarty pants. You guys just want to show everybody how smart you are? 6 and 4? Yeah, this killed the thinking for the rest of you, eh? What a bunch of guys, eh? So it's 6 and 4? How do I know? I don't know. Just put down 6 and 4 and think. Okay, get me to 24. Which one's got to be negative? The bigger one, right? Boom. -6n plus 4n. Don't forget that variable, or else the next steps are going to look funny. Put the under brackets. 3n, you're going to get a n minus 2. And then take out a 4. And you get n minus 2. N minus 2 comes out and you get your 3n plus 4. What do you guys think? Enough is enough? Enough is enough. Okay, what were you going to do with class example 5? Rearrange it. Good. And for class example 5, I would rearrange it, and then what, Carl? Only Carl. Which one are we on? 5A? Look at it, please. What would you do with that negative out front? Look at it. Remember we talked about this?
Put it
Yeah.
outside.
You didn't even take those notes. Oh my gosh, Carl. Yeah, you gotta get rid of that negative, or else it's gonna just look funny. This negative on lead coefficients, the bane of my existence. Lead negative, get it out. Take out a negative, you get 2y squared plus a 7y minus a 15, and then factor that business. Over on 5b, and remember, you got to finish this one. Finish it for yourself. For class example 5b, what do you notice? Do you want to do 15 and 10 goes to 150, or is there a better way? GCF, right here. 5? So you get 3k squared plus a k minus a 2. And it's way easier to work with 3 and 2 making 6 than it is going up to 150. Because then when you finish factoring it, you wouldn't be done. Oh my gosh, the hard ones are now upon us. These ones down here where they have a variable on the front and the back. Okay? But it's the same process. You with me? We'll just do these two and then we're done. We'll go slow on these ones because they seem weird. Okay, do the same thing there. I need two numbers that multiply to 4y squared. What's the structure that these have? Do you remember? ax squared plus bx plus c. So we need to find the AC, which is what? 2 is A, do you agree? And C is all this. And what's B? -5 y. X is X. Look at this. I'll use my pointer. Okay, x squared is x squared. Do you agree? So A is 2. You with me on that? Okay. C is, well, all this. You okay with that? Now bx, well, x is x. So B is -5y. Okay. So this is the AC and this is the B. And if you think about it, without the variables, you might have success as well. What multiplies to 4? 2 and 2, or 4 and 1? Good. Which one of those is going to get you to 5? 4 and 1. They both have to be negative. Okay? So how will I break this down? I'm just going to rewrite it. And this is where the 20-1 part of the factoring, like, it starts. Like, this is where we get into some real questions. So we got to break down the middle term. That minus 5 is going to become a minus 4xy and a minus 1xy. Now I can jump into these pairs. What's coming out of that first pair? 2x. You get x minus 2y. You okay with that? What's coming out of that second one? How do you know it's negative, girl? Good. Look at the orientation here. It goes plus and then minus, and then that's that pair. This pair goes minus and then plus, so it's the wrong orientation. Okay? So if it goes plus and then minus and then minus and then plus, it's messed up. So you have to factor out a negative. And what was the number? Just a variable y. Take out negative y, the signs will change. You'll get positive x and negative 2y. Now you're breathing a sigh of relief because they've matched, right? Right? And you get this business here, where you take out the binomial and you're left with the 2x and the negative y. I live for this stuff. Isn't that sad? It's because it's so structured and ordered and it never makes you mad. Never breaks your heart. unless you can't do it. Do you guys still need that stuff? Okay. Okay, let's try the next one, and then it's going to be the east period. So. Yeah, personal east. Okay, AC is what? And there's lots of M's and N's, those messing me up. What's like the X? I like to jot that in underneath so I don't get screwed up. AX squared plus BX plus C. So what's squared? What's being squared? The N. So the N is the X. Okay. So what's the AC? It's going to be 2 from over here on the left, and then times 35m squared, negative. So it's going to be negative 70m squared. Okay, and then what's the B? And this is where it gets pretty dicey. I'll go Duad. You're so good at recognizing these symbols. Daoud, sorry. Did I say Duad? Oh my god. I need another coffee. Alright, so what's the magic numbers? And if it's messing with you, ignore those M's. Just ignore these M's. What goes to 70 and 3? This, oh, you guys are so good. It's 10 and 7. I don't know what the signs are though yet. Negative 10? Are you guys comfortable with that? Because it's going to end up negative after you add them. So the bigger one has to go. Okay, lovely. Copy down the first one. Copy down the last one. And in the middle you decompose. Minus 10 NM. Don't forget that. Plus a 7 NM. And then put them in the GCF pairs. Jumping out of the first pair is 2 N. Very nice. You get an N minus 5M. Gotta enunciate. Take out a 7 and an m. Good. And you get n minus 5m, and then you say hallelujah because it matches. Take out the matching binomial, you're left with 2n and the 7m, and you do this little symbol. That's what they do in Asia. Right, Jimmy? They do that. I learned that from a student. Keeps everything nice and neat. Means I'm done. Okay, homeworks, 3 to 8. We'll pick up this, later on, this stuff. So let's just do what the homework said. It was up to 8. So try as many as you can, 3 to 8, okay? And don't worry about algebra tiles. Don't worry about algebra tiles. You can try them just using regular algebra, but it said 3 to 8, and there's lots there. So if you want to just run through the first column, do that on the weekend. What are you doing tonight? Studying for trigonometry. Don't forget, right? I have a trig test tomorrow, right? Circleometry. All right. When that bell rings, you guys have a great day. But until then,